All right. This is VSEPR theory shapes. You have a little bit of this at the back of your reference sheet. Although you have that, you still need to understand how to do the shapes and what they mean as far as their polarity and forces. So we first have linear. This shape's the simplest. We have the idea of it goes in a straight line. This is the way it's modeled. And that either of the two atoms, whether it's two atoms or if we have three atoms, have no unshared pairs on the central atom. See, nothing around there. If it's bent, this is similar to linear, but this requires a central atom and has unshared pairs of electrons. These get kind of forced downward. So you can see the idea of bent compared to linear, no lone pairs of electrons. Trigonal planar, similar to bent, but instead of there being an unshared pair, it's a bonded pair. So this would make that you'd see no unshared electrons, but that means that these are able to kind of be at the ends of an equilateral triangle for each of these. So this is why it's going to be flat, and we can represent this all with lines. We represent lines in this 3D modeling for this here. Trigonal pyramidal. So this is when we have a Lewis structure that has unshared pairs with three bonded atoms, like these. So these are all Lewis structures. However, a structural formula, or 3D structure, needs to be shown like this. Gives it a three-dimensional shape. Now, when you have a line, that means these are in the same plane. So they're all kind of just two dots together. Sorry, two elements together. This one, which shows this black triangle, is meant to show that the fluorine is coming towards you if it was in a physical three-dimensional manner. This one here shows it going behind the nitrogen. That's what's going on here, behind the phosphorus, in front of the phosphorus, in line with the phosphorus. I'll show a way that I like doing it myself. You can do it this way and others. However, I always like it one way for myself that I do regularly. The last one is tetrahedral, similar to the trigonal pyramidal, but it has four bonded atoms instead of three and a lone pair. Again, this is a Lewis structure. This is a 3D structure or structural formula. So this is a good example where we have this hydrogen, carbon, hydrogen, all in the same plane as if they were laying flat on the paper, with this hydrogen going behind the paper and this one coming up out of the paper, kind of coming up off of it. We're going to take a look at all of these together and make kind of a, not a cheat sheet, but like a representation, there we go, of all of these so we can keep it all together and tie it to polarity. So let's take a look over at part 2.